packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Costello. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes.
We're glad you've joined us. Today, we're going to be talking with our guest, Tom Costello, about the IPv6 work done at the SC24 event that happened at the end of 2024. For those that aren't familiar with SC24, why don't we start there? Tom, you want to give us a little bit of explanation of what SC24 is?
Certainly. Thanks for having me, Nick. So the full name for the SC conference series is the International Conference for High Performance Computing, Networking, Storage, and Analysis. Almost nobody calls it that. We typically go with SC and whatever the 2 years of the conference was. So last year it was SC24. This year it's SC25. And I've been volunteering with SciNet, which is a part of the SC conference series. So we build the world's largest temporary network. We had this year over 18,000 people attend the show floor, which is really great. And on SciNet, we both build the network used by conference attendees to just, do general purpose Wi-Fi, stay connected with their day job during the conference, that sort of thing. But much more interestingly, there's also a whole bunch of science that happens on the show floor. SciNet network research exhibitions. There's another workshop called Innovating the Network for Data Intensive Science, that has all types of really fascinating things with research and education networks happening at this event. So I've been volunteering with them for, I guess 3 years now. SC22 was the first year that I helped out with this. Some of my coworkers peer pressured me a little bit into checking it out. And at SC22, that was the first year in quite a while that IPv6 was starting to get treated as a first-class citizen. Everything was starting to get dual stacked, which was great. And at SC23, they took it up a notch, and we deployed out an RFC 8925 network for wireless, which, again, big step in the right direction. And this year, we did some pretty interesting things on our special IPv6-only Wi-FI SSID for the entire conference called SC24 v6.
Yeah, that's cool. I do have a question just for the audience. RFC 8925, want to quickly cover what that is so that we don't skip over that quickly so folks understand or have some context there.
Definitely. So RFC 8925, better known as IPv6 mostly. So this is the magic where if you have a client that supports it, so right now mostly Apple and Android devices, with DHCP v4 option 108 will enable the client-side translator on those devices so that the device effectively goes IPv6 only, drops the IPv4 address family, and uses NAT64 and that client-side translator to still maintain reachability to the IPv4 internet. And I know it's always hard getting Wi-Fi statistics just because, so many clients join and then leave and all of that stuff. But we had somewhere in the ballpark of 2,000 clients go v6 only at SC24.
Oh, that's impressive. How many total attendees or devices do you think is actually at the event?
So total attendees was definitely over 18,000. And it's really hard nowadays to get the unique device count just because so many people, where we have some, let's call them power users, where someone might be running, multiple VMs or even a Kubernetes cluster on their laptop that they connect into these environments. And for every single thing that grabs an address, again, depending on how you slice the cake, I feel that every single one of those things grabbing an IP counts as a device. Other people might feel that, one laptop is one device, right? So it's hard to get exact numbers on that front. If anything, it's more difficult to do that nowadays than it was, 10, 15 years ago, but a sizable number of clients, to say the least.
Yeah, it gets back to that classic definition. Let's talk about hosts, and then a host has a unique IP, and then it's easier, and then you don't care. You could have multiple hosts on the same device than physical device, right? That's cool. You've been involved in doing the work. What in the world made you interested in doing IPv6 work?
Quite a few things. I'm glad you asked that because prior to about February 2022, I was actually not really into the whole IPv6 thing. I would learn the bare minimum to do things like pass the CCNP certs and things like that, but then not really do it in my day job. And so February 2022, I was coming back from parental leave and I asked my boss, hey, I want to do all this stuff with zero trust. I want to build out this proof of concept. He was like, that's great, Tom, but it'd be really a shame if you do all of that and just have to redo it all for IPv6 only in the future. future because we have that IPv6 only mandate at my day job at Argonne National Laboratory. And so kind of begrudgingly at first was like, okay, fine, I'll get better at IPv6. I took a training course, and throughout that year, Energy Sciences Network was also deploying new routers to the site as part of their ESNet 6 initiative. So we had to redo a lot of our BGP peerings up to all of our ISPs, including ESNet as part of those refreshes. And so I was very much incentivized to, learn IPv6, get better at it, so that when we did all of those cutovers to the new routers, I wouldn't be breaking anything in production. And it wasn't actually until later on that year. So SC22 was November 2022. Of course, there was a renewed interest in V6, given that there was a lot more attention on it. And we finally built out our IPv6 only test bed at Argonne. That would have been December of 2022. And that was the first time that I had seen firsthand in my own environment Net64 actually working. I saw it before in a classroom. I saw it, reading about it, but to actually see firsthand some of the internal web applications that we have, some of which, what's a nice way to put it? They're a little bit on the legacy side, which is fine.
Yeah.
Any organization that's been around a while is going to have some technical debt, and we are the oldest national laboratory. So to just see some of those quite antiquated web apps that we're trying to replace and renew and all that stuff, but to see it work from an IPv6 only workstation was just fascinating to me. I thought that none of that stuff was going to have any chance of working from V6 only, and to actually see it with my own eyes, that was really the turning point for me, to be honest. Once we had that testbed working and we're able to see some good results from the V6 only clients.
Yeah, it's nothing like, oh my gosh, this actually works. We could actually do this as a light bulb moment of saying like, yes, we could actually get to V6 only in those scenarios. It's very cool.
NAT64, especially with CLAT, is a heck of a thing. It's a marvel.
It's pretty remarkable. Well, I mean, it's proven technology now, just in terms of like
Yeah.
all the mobile providers and how heavily they're making use of it. So if there were true holes in it in terms of legacy support, we would be seeing that pretty dramatically just from the mobile network side of the carriers. So, many thanks to T-Mobile and the folks over there to make all that a reality, right?
Yeah.
That was a big deal. Well, I guess we get around and talk about what you actually did for SC24. Let's get into the weeds and let's talk about, what goals did you have in mind around the work there? What was the goals that SC24 actually had around experimenting with V6? What work in the past informed what you were doing today, I guess would be a good lead in. Like, what was it about 22 and 23 that led into what you were doing in 24? And let's talk a little bit about what sort of experiments you were running on everyone there.
Definitely. So at SC23, that was the first time that I was connecting to that RFC 8925 environment. Typically, my daily driver for work is a Windows laptop, which unfortunately, even though it doesn't support RFC 8925 quite yet, because we were sending out the DNS64 servers, both through the IPv6 RAs and through the DHCP v4, sending that DNS option so that everything was kind of forced to use DNS64, even the dual stack devices. So to really push the needle, trying to get as much IPv6 usage as possible at SC23. So I was really happy with that. But one of the things that really annoyed me was, and was actually here at Argonne. So I'm part of the Argonne Amateur Radio Club. We have this, it's called Echolink, and it's an IPv4 only service. To my knowledge, I don't think there's IPv4 literals in the application. It's pretty old, dated, but it works. And we had this special event that we were doing, and I was connecting into this IPv4 only amateur radio setup from an IPv4 only device while I was on the SC23 V6 network. And it just felt kind of dirty because I obviously wanted to use the V6 mostly, I should say, network at SC23. But the fact that I was connecting an IPv4 only device onto this wireless network, connecting to an IPv4 only server, and everything just worked. Although I think that is one of the good things about RFC 8925 is, you can naturally, as you refresh equipment that supports the RFC, start going V6 only without dropping that IPv4 only compatibility. But it's also super misleading because what if I'm, let's say, higher up at one of the agencies that has the IPv6 only mandate, and I connect to SC23 V6, I connect into my agency's VPN. I think that everything is fine and great when in all reality, my laptop that's enterprise managed might have had IPv6 disabled the whole time. So I felt like I was almost doing a little bit of a disservice with the way that we were promoting all this V6 mostly stuff, but v4 only devices would still work on that network. So for SC24, we did some interesting things. We ultimately did this through DNS record poisoning, but originally we thought more of like a captive portal experience, where if you took a v4 only device and connected it to SC24 v6, very similar to like if you're on an airplane and you don't pay for the Wi-Fi, maybe you can see the flight map, maybe some entertainment, but you don't get the full internet. That's the experience that we wanted to replicate. So if you took a v4 only device, joined it onto this network, you would have a very obvious captive portal type experience that says, hey, thanks for trying, but too bad, so sad. Your v6 is either misconfigured or completely disabled. Go to the help desk and talk about it from there, so that we're not misleading people into thinking that devices with v6 disabled, but we're actually talking v6 on that SC24 v6 network.
Yeah, okay. That makes a lot of sense. What I admire the most about the V6 community is how seamless they have made the experience for people to move from V4 to V6 and not know which network they're on. It's been a huge, I think, feather in their cap in terms of really making that transition as seamless as possible, starting all the way back from Happy Eyeballs and the work that Dan Wing and you, Jaco, did way back when. I don't know, was that 2010 or something or earlier? So I think that's super important. But the reality is, like you indicated, there's no way for end users to really know what's going on. So a little bit of data, a little bit of that information turns out to be incredibly useful for them. I agree with you that it's important to be able to do that. And it's funny that the amateur radio apps have embedded IPv4 in them. But what's your call sign, Tom?
Yes, that's actually the best way to find me on the internet. It's KD9CPB. I've always been bad at the whole like having an internet nickname thing, so I just went with my ham radio call sign that's been assigned to me.
Yeah, fair enough.
I'm the only KD9CPB out there.
All right. Well, mine's Kilo Delta 6, Mike Yankee Mike. So
Mine's W9NDB. Gosh, we're all ham radio. So I want to circle back around to something that you said just very quickly, because when we talked about this before, it was something that is very obvious when you say it, but it had not even occurred to me. I was like, oh, actually, that's a really good idea. You mentioned that you handed out the DNS64 resolvers along with the option 108, and you handed them out with DHCP v4, meaning you were essentially forcing things that even if they had IPv4 to use IPv6 for everything that's essentially not a literal, right? Again, when you say it out loud, yeah, that makes total sense, right? You're doing a DNS query. You've got to, as long as you are not v4 only, it's always going to default to v6 unless the application's doing something funky. And so you can essentially force probably 95 to 99% of your traffic over v6 by simply doing that, even if you have a dual stacked host. And I think that was really kind of a happy discovery, I think, at least for me, because I remember talking to you and you said you were going to do that, and you said it like, everybody knows this, right? And I was like, I've been doing v6 a long time and I'd never even considered that. So I thought that was a really interesting way to do it, especially because you've got a bunch of transient clients that are coming on and off the network. You have no control over any of the endpoints, right? It's a conference network. So who knows what's going on, right? For those clients that have v4 only because their corporate policy disabled v6, they'll just happily work with IPv4. So I think that that's something that I've never really heard stated in such a sort of succinct way, but it worked really well in the cases that you used it for. And I just wanted to highlight that. Maybe I'm wrong, Ed. You can go, no, everybody thinks about that. You get your head in the sand.
No, I don't think you're incorrect. I mean, the standard recommendations for most enterprise groups, this show is obviously different than the standard enterprise environment, but, most enterprise groups, you would tell everyone, you don't want the DNS64 resolver to be visible to anything except for IPv6 only client networks, because you don't want people trying to force through to do translation. So that's the typical normal response. And so your gut instinct is correct, Nick. Why would you do this? But I think the use case for a conference and for what you guys are doing, it makes a tremendous amount of sense. And, you can still do recursive resolving. If you put the logic in the DNS server, you can still do recursive logic to basically say like, well, there's v4 only available. And we can do some behind the scenes if something odd comes in place, which is the redirect that you guys are talking about, right? We're redirecting you to the page that says like, hey, you're a v4 only client. Are you aware of that? You're aware that you're not even using the CLAT. You're aware that your app can't even make use of the DNS64 function that we do provide. So I think being able to capture that, you have to do a little bit more work there in order to sort of redirect that. I imagine you guys had to do a little bit of magic behind the scenes just in terms of saying like, hey, all these other things, we're going to redirect you to this particular website in order to get that to function. So I don't know if you want to talk some details around that, Tom, but that would not be the normal setup that most enterprise shops would do, right? So.
Yes, and I think that's probably the most fun part of this paper that we wrote. So it's entitled Improving Transition to IPv6 Only via RFC 8925 and IPv4 DNS Interventions. And I know that's a huge mouthful to say, but what it boils down to is we had 2 additional DNS64 servers set up specifically for this use case, where they were actually running DNS mask, dirt simple config. All that we had DNS mask doing was any quad A queries that would come in, so from v6 only or dual stacked hosts, go ahead and forward those to our regular DNS64 server. Don't mess with the payload at all, just normal DNS. I don't know if proxy be the right word, but just pass along the traffic, forward it on, everything's normal. If you have a record request come in, DNS mask, and it's only 1 line of config, it was surprisingly easy to do. No matter what anyone would ask for an A record query, it would respond with the IP address of our test-ipv6.com mirror. So when we were first testing this out in the test bed, we used the actual test-ipv6.com. We had some issues. They are documented in the paper, but the idea being that the really nice thing with that website is it's open source. You can make your own mirror of it. And because of that, you can actually have custom instructions. If, let's say, you get a 0 out of 10 score for your test-IPv6 results, you can say, hey, contact your help desk, walk over to the SINET booth, etc. And so normally, DNS poisoning is a little bit frowned upon. It doesn't sound like a pretty thing to say. So only the v4 only clients should be the ones doing those A record requests. And for all the dual stack clients, and again, I know Windows and Linux get a little bit weird. In most cases, in Windows in particular, it'll still prefer the IPv4 DNS resolver that it received through DHCP over the v6 one it received through RDNSS and the RA. But it was very interesting because it worked as we thought it would, except for a handful of applications, Slack being one of them. And I still never fully figured out why this is, if it's just something baked into the Slack client, because Slack is still v4 only as of this recording, or if maybe it had something to do with Happy Eyeballs, if I think they have some type of web browser that's the back end of it. Either way, Slack just seemed to have some issues with this. So we changed our DNS mask config at the conference to basically allow anything that ended in slack.com and a handful of other, like the CDN they use and that sort of thing. We just gave that a free pass through the DNS poisoning so that even the dual stack clients that were having issues with that would effectively work around it. To my knowledge, there was a handful of, again, little onesie-twosie issues here and there, a lot of stuff that we've already known about from the SC23 experience, but I would say it went better than expected. We did not have many complaints about all of these IPv4 only interventions to get those off of our wireless.
Yeah, that's really interesting. My guess would be that they're doing some sort of direct DNS query lookups in Slack internally, and they're bypassing everyone else's DNS servers because they don't trust them, because they don't want their stuff redirected at all, is my guess.
I was just going to make a clarification because we use the term Slack. We're talking about the chat application and not the address dissemination mechanism within IPv6.
Good point, Nick. Tom, you're correct. The order of preference for DNS namespaces in Windows, the DNS name resolver from DHCP v6 is first, and then it goes to DHCP v4 as a name server preference, and then it will fall back to the RDNSS information learned, which is unfortunate. And those are hard limits. So if it didn't learn at any point the DNS name resolver via IPv4, it will never fall back to the RDNSS one. So even if you have it in there, and even if it's active and working, it does not matter. I don't know if Tommy Jensen over at Microsoft is planning on changing some of the behavior on that, or at least allow you register your key to say, like, I'd like the following order of operations to occur so that you can modify the order of operations and actually allow it to fail over. There's no failover today that I'm aware of. So if you get something with DHCP v6 and for some reason that DNS name resolver is offline, but the one that you point to with RDNSS is available, it still won't fail over to it. So sort of an interesting use case scenario. It's a little corner case there. I don't know why you would list a different one in your DHCP v6 versus your RDNSS. So maybe it's a moot point. right? That would be a little strange anyway.
If there's a mechanism to do something, you can guarantee someone will do it for whatever reason somewhere, right?
Yeah, it's probably just misconfiguration, right? Than
Yeah.
anything else. Were there any other issues or problems that you sort of ran into as something visibility wise within the conference? Although this sounds like that was probably the major sort of showdown in terms of what you were doing, but I didn't know if there were any other little nuanced things that you might have noticed, good technical details for the audience that they might be interested in.
Yeah, so in our paper, we have a solid full page of talking about some of the VPN troubleshooting issues that we had inside of our test bed. It was very interesting getting to the SC24 show floor because I was actually not able to replicate the VPN issue that I was having on my Argonne VPN in this test bed. I'm still not entirely sure why. Cautiously optimistic that once Windows 11 gets that RFC 8925 support, I can really deep dive. I'm more of a Windows daily driver type person. I know enough about Apple to get by, but since I don't have Apple laptop that I can very easily test on the VPN, we've been kind of waiting to dig deeper into that. But the good news is a lot of the VPN issues that I thought we were going to have, we didn't have. There was still a handful of, again, mostly related to split tunneling, where you're split tunneling, and especially if the application that you're split tunneling, something like, Slack, Microsoft Teams, etc., is still v4 only. It just gets a little quirky where you're trying to ride that client-side translator to split tunnel the traffic, but it seems that in some cases that does not work as designed. And again, I know that we didn't have as many of those issues as I was expecting to have at SC24, but there were a handful, and I'm cautiously optimistic that once we get that more and more RFC 8925 support, that both the VPN vendors out there, the ones making the clients, and the operating systems themselves will handle that a bit more smoothly. But I would say the VPN issues are probably the biggest pull in the tent, so to speak. And then this next one was a much, much smaller issue at SC24 than it was at SC23. But the fact that RFC 8925 does a really good job of disabling IPv4, even if your v6 stack may or may not be functioning. So a great example of this is if you have an enterprise managed machine where there's a host-based firewall rule saying, hey, just block everything with an ether type of IPv6. So if you have a Macintosh computer that has that, but you receive that DHCP v4 option 108 that says, hey, go ahead and disable the v4 stack, you're just kind of stuck. It's very much not a good spot to be in. That was a big issue at SC23. We were originally trying to do RFC 8925 on the main wireless network for the whole show floor. And because of that issue alone, we had to quickly pivot to, no, let's lock that back a little bit. Let's have a separate SSID for the RFC 8925 stuff. Fortunately, we did not see anywhere near as many issues with that this year, or I should say at SC24 than at SC23. So I feel like that's both a testament to, as more and more organizations adopt IPv6, we're expecting to see fewer and fewer of those issues. Then, of course, as the operating systems start supporting RFC 925, it just becomes more and more interesting from a deployment point of view, where theoretically we could have a very small pool of IPv4 addresses. Because RFC 925 never results in the DHCP lease process completing, it's not burning up IPv4 addresses from your DHCP v4 pool. So theoretically, you could have a /24 that has 1,000+ clients on it that are going v6 mostly, thanks to RFC 925, and not have to mess around with resubnetting or any of those headaches in the v4 world.
Yeah, I think that's a really important point. I think many people don't understand that they sort of short-circuited the DHCP process and don't actually assign an address out unless you actually need it. So unless you complete that process on the handout. I think Microsoft's, Windows 11 is a little bit of a laggard in terms of support for this functionality. There is client support available even in Linux hosts to do this process. So I think it'll be really interesting seeing when those that do need to make use of this particular technology to help them get to v6 only, that this becomes sort of, I almost consider it like a belt and suspenders approach, Tom, around like you got DNS64, you got NAT64, but what do you do for all those applications that fall through that can't do something with DNS because, something was hard code embedded in the application of some type, from a literal basis. And so with those use cases, having this as an additional tool in your pocket, but not paying the penalty for handing out so many IPv4 addresses actually becomes a super desirable thing to do, because it gives you the capability to go ahead and deploy without necessarily having the headaches of orphaning devices on a given network, nor having to allocate a lot more IPv4 for the client-related networks that you are on. In other words, you don't have to change the size and scoping of them to be able to support this. So I think flexibility-wise, I think the V6 community is putting the right tools in place for folks. Now we just need to get IPv6 mostly to not have to be a Slack-only solution, and not Slack as in the client app, but Slack is in the IPv6 stateless address auto configuration side. So if it actually has a DHCP v6 PD option, that would be pretty cool. Just sort of having that as an additional tool in the tool belt, I think would help a lot of organizations that have probably higher security requirements than what Slack might allow. I mean, I imagine the supercomputing conference, the security, tracking every single device, things of that nature is not high on the list of things that need to happen per se, except for maybe for troubleshooting, in the same way that maybe in an enterprise environment, you might be trying to solve that particular problem, right? Or maybe Argonne has this issue, right? Where you're trying to track everything that's going on in the network because you need to know, right? You have a requirement for that. So that becomes something a little bit harder. What do you see for V6 sort of next in terms of, I'm assuming you're going to continue doing work for SC25, right? So what's the next thing that you are really sort of seeing that V6 could be interesting, besides obviously expanding your experiment here and hopefully having Windows 11 as additional client to get more data and input around what's going on? But what do you foresee as additional V6 things that might be interesting?
I think one of the most interesting things we can be doing on the SC25 show floor is, in previous years, we have this environment called EduRoam. So throughout the research and education community, it's kind of like a federated login system where I can use my Argonne account to connect into this EduRoam Wi-Fi somewhere like Northwestern University or Berkeley Lab, et cetera. It just makes it so that throughout the research and education community, you don't have to deal with guest Wi-Fi at every single campus you visit. So we are a huge fan of that. At SINET, we set up this EduRoam SSID, and it's a double-edged sword because it's a great thing because for most people, it just works. They roam onto EduRoam. They don't even think about which wireless network they join because the Wi-Fi is just there. It's just working. It's great. And previously, we have been of the opinion that we want to keep EduRoam dual stack because we want to have the same consistent EduRoam experience, whether you're on the SINET floor, whether at your home institution, whether at some other campus. But I feel like we might be swayed more towards maybe we should do RFC 8925, not with the IPv4 DNS interventions, not trying to kick off v4 only devices, but regular plain RFC 8925 on EduRoam for SC25. Again, now that we've seen, I believe there's one institution out in the United Kingdom that has done this on their college campus with great success, and just being able to see, especially as more and more operating systems get that support for RFC 8925, just how many devices can go v6 only, in many cases without the end user having any awareness as to the fact that they dropped a v4 address.
I have relevant data regarding this. So as an example of the powerful nature of EduRoam, so I go to IETF meetings and collaborate with, other institutions, and almost always at the other institutions, EduRoam is available. So I can just log in with my home institution credentials, get in, no problem. Supported at IETF. I roamed right onto it, didn't even realize I was on EduRoam. In my local office, which is a small office, it's not, there's less than 20 people in there, but we have EduRoam available in there. And as of a few months ago, we decided sort of unilaterally, because, we're sort of the pilot office for a lot of experimental stuff. We just put option 108, RFC 8925 on our EduRoam network. And we did it right before sort of a larger meeting was going to happen in our area. No problems at all. It wasn't even mentioned. Actually, I didn't even tell them until like weeks later, like, oh, by the way, that was option 108. IPv6 mostly on our EduRoam network. EduRoam's very prolific, and I think EduRoam's a perfect use case for IPv6 mostly. And I know I'm sort of rambling here, but I would encourage that as at least something to be considered for a larger deployment, because I think it does work very well there.
Definitely. And one of my favorite things about SC24, 25, and hopefully at SC26, maybe we'll even be able to kind of further move the needle and do RFC 25 on the main wireless network. If we're lucky, again, I feel like we'd have to have all the operating system vendors support it before such a thing could be considered. But at SC, we are not the first conference to mass deploy RFC 25. I think to a certain degree, we're actually not even doing it the best. I know that Apricot conference in Asia Pac, they've done some really, really cool things. I think they've even contributed some code to RadVD and some of the other things that you would need to do it well. But the fact that at SC, most of the people connecting to this Wi-Fi are not network engineers. They might not even have a whole lot of network experience at all. We're kind of, again, anyone that's in that community for HPC, high performance networking, storage analysis, you get literally a little bit of everyone. And the fact that that group, again, and not trying to talk trash about the other conferences, I think it's great that we see RFC 25 at your Nanogs and your IETFs of the world. But the fact that it's a majority non-network engineer audience and everything just works, that makes me very happy. And I think that's part of what makes the SC conference series so special when it comes to V6.
Yeah, it's also very large, right? It's very
Yes.
large and it's purpose built.
There it is, Tom doing trash talk on Nanog and IETF. The gauntlet has been thrown, everyone. But no, that's totally awesome. I do really admire what you guys have done in terms of providing useful data back to the community. I think most importantly in the form of your paper and really allowing people to get very clear data insight about what worked, what didn't, what to look out for, and, you know, potentially how this can help them to move forward to solve, you know, some pretty difficult architecture issues, to be honest, because there are many shops that are really struggling about the V6 only side is not as simple as everyone likes to think it is. And this sort of interim step that allows you to have a portion of IPv4 there as a fail-safe, as a sort of belt and suspenders approach, I think it's very useful because there are use cases where you can't get around certain things, whether there are policy enforcement portions, whether they're just limitations from a hardware and manufacturer basis that you're just stuck with that you can't move beyond. And let's face reality, redoing VLAN and subnet configurations across your entire enterprise network may not be something that you can easily achieve, or you may not have the IPv4 space to do it as a secondary portion. So having the capability to convert that over to V6 mostly, maintain what you're doing, but then be able to move clients over in an efficient way to V6 and be able to hit your target goals, I think is super important. So you folks demonstrating that you can do that in a pragmatic way, I think has been super helpful to the community overall. So I really appreciate all the work that you guys did around that. It's been super important for folks to hear about it and to be able to read about it and see the tangible results of like, yeah, this works in the real world. So thank you very much for that, Tom. I really appreciate it.
Thanks. You're most welcome. And I'm sure we'll have a link to the paper in the show notes. And by all means, please try this poisoned IPv4 DNS server idea at home. I would love to hear more from organizations, both those that do need to support IPv6 only for whatever the reason, whether it's due to a mandate or just because you don't want to deal with the agony of NAT44 anymore. I think there's a lot of good use cases for this type of deployment. But if you're somewhere that doesn't need to go V6 only, if let's say, you're a university where you don't have control of what people are bringing onto your Wi-Fi, and if you disable the IPv4 only Nintendo switches, you're going to have a bunch of students coming after you with fire and pitchforks and stuff. If you're in that type of environment, you're probably better off with regular RFC 8925, taking no efforts to kick off the v4 only clients. So again, this is not for everyone, but I think there are some good use cases, especially if you're trying to go v6 only, an environment where your end users are not very familiar with network engineering or really any type of v4 versus v6 type stuff. Having that pop up, that captive portal in your face that tells you your device isn't supporting v6, I think that adds a lot of value to help desks that need to support the v6 only client base.
100% agree. Well, Tom, how can folks get a hold of you? What's the best way for folks to reach out if they want to chat?
I'm pretty easy to find on the internet. If you just search for, again, the ham radio call sign, KD9CPB, I'm the only one out there on most of the social media platforms. So that's probably the best way to reach me. And then if you want to learn more about SciNet or the SC conference series, scinet.supercomputing.org is the place to go. SciNet's mostly made up of volunteers from the research and education space. So most of the organizations, so Energy Sciences Network and Internet2 are kind of the big two internet service providers that pull it off. stuff. Many others and many of the vendors that provide us the gear to do all these amazing things are also involved. But definitely check it out if any of this is of interest.
As a 20-year alumnus from SciNet, I can say it's one of the best interop and experience related endeavors you can take on. You really can't get this kind of experience anywhere else.
Fantastic. Well, Tom, thank you very much for coming on. I really appreciate it.
Thanks so much.
Yeah, thank you.
Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.